Hello student, today we are going to discuss about block diagram. So in this topic we are going to discuss about some block diagram and block diagram reduction technique. So in this class I want to discuss what do you mean by block diagram. Generally, a control system contains a number of components. So the function of each component can be represented with the diagram called as block diagram. So a block diagram is nothing but a pictorial representation of the components in together in a control system, and the signal, that means flow of signal through of component. So block diagram is a pictorial representation of components in the control system. So a block diagram is basically modeling of any simple or complex system. It consists of multiple blocks connected together to represent a system to explain how it is functioning. We know the transfer function. What is transfer function? Transfer function is basically the transformation relation between the transformation or ratio between the transformation of output to the transformation of input when all the initial conditions are 0. This is a simple system, means this is a simple open loop system. So what is the transfer function of this system? Transfer function of the system is GS, and this GS is equal to CS by RS, and we find easily the transfer function of this simple system. Now you have seen a complex system where so many blocks or so many summing points or so many signals are connected in together. So it is very difficult for us to find the transfer function of this system. So to find the transfer function of this complex system, we use block diagram reduction technique or block diagram reduction. So what is the need for block diagram reduction? Block diagram is normally required to reduce multiple blocks into single block, or for convenient understanding it may sometimes required to rearrange the blocks from its original order. For the calculation, because for calculation of transfer function is required to be reduced. Okay. So block diagram is basically a pictorial representation of components in the control system. Here we are having so many elements in a block diagram, because you have seen in this complex system there are blocks, summing point, then this arrow means signal. Okay, so here in block diagram we are having so many elements in a block diagram. So many elements means generally we are having basically we have this basic element like blocks. This is blocks, where is mentioned is system. This is blocks, then summing point or summing junction, then branch point or take up point, or signal. Basically three main component means blocks, summing point and take up point or pick up point, branch point. Okay. Generally, a block diagram will consist of these three elements: a block, a summing point, or a branch point. Now coming to the block. Block will be like this. It represents a square or rectangle. It is a junction point. Whatever the system parameter are there, so those are going to add here. That means whatever signal you are passing, that signal will pass through this block. Block is having some gain or transfer function. So here the transfer function is indicated by GS. So this block is having particular gain, and the gain is G. If we are going to represent the transfer function of the block, I am going to represent it by GS. So block is nothing but a junction point. It's like a junction point. Or so here, if you see this block, a signal is entering to the block. So whatever the signal entering into the blocks will indicate by arrow, and this is like this, where signal RS or CS is indicated by the arrow. And coming to the summing point. Here the signal are going to sum or subtract. Here in the block, signals are going to enter into the block, means block diagram. Coming to the block diagram, here in the block, signals are going to enter into the block. According to the block functionality, the signal is going to modify. According to the gain of block, the signal is going to modify. If you are having signal R here, and the gain of the block is equivalent to G, then the output will be, output means CS equal to RS into CS. For example, if the gain is 1 by G, then the output will be R by G. So whatever any signal enter into any block, according to the functionality of that block representing a component, the signal is going to vary. According to the characteristics of that block, your signal is going to modify. So coming to the summing point. Here we can say this is a combining point or adding point or subtracting point. So this is summing point. Add 2 or 3 more signal. By this summing point, we can add 2 or more signal. By this summing point, I can add maximum of 3 signal. So by summing point, we combine the signal. Here the signal is R1, R2 and R3. Okay, so the output is R1, R2, R1 plus R2 minus R3. Now coming to the pickup point. So this is the point from which signal will go from a block concurrently to other block. Okay. So pickup point, or whatever it is called, branch point or take-off point, it is a point from which a signal will flow concurrently from a block. So these three are the very important element in the block diagram reduction. So generally, block diagram is nothing but a pictorial representation of components in control engineering. So it will show it will show of the function of components and signal flow. It's having three basic components, and the components are blocks, summing point and pickup point. Now here we are discussing about the block diagram reduction technique. Now here we are discussing about the block diagram reduction technique. So why we need block diagram reduction? So for example, any control system is given in terms of block diagram. As I already told earlier, block diagram is a pictorial representation of each and every component in control engineering or control system. So if any control system is given in a block diagram model, so that is identification of all component in blocks, signal flow and summing point and branch point, like that. So if we asked about what is the transfer function of the system, generally you know what is the transfer function of system. Transfer function is the ratio of the output transform to input transform with all initial condition 0. So if you have small block diagram, then it is easy to solve out the transfer function of the system. But whenever you have so many number of blocks, so you estimate the transfer function or any other problem on that block diagram perfectly. That's why we need to reduce the block diagram. Reducing the block diagram is better because we can reduce the complexity of the structure, or we can find out the transfer function easily. We can find out the gain easily. So for all these purposes, we are going to reduce our block diagram, but we need to follow to reduce this block diagram, but we need to follow some rules, and these are the important rule. So we must follow these rules if we reducing the block diagram. There are various rules like cascade connection, parallel connection, interchange of consecutive summing point, shifting of a takeoff point from a position before a block to a position after a block. There are 10 to 11 rules are there for reducing block diagram, which I will discuss in next class. Okay, thank you student.